All right, guys, we're going to look at some of these. They're like little quizzes from each section, but we didn't do them as quizzes, so we're going to do this as part of our review, and let's just kind of see what we can get through here. Okay, we started off this chapter by just doing some very simple integrating, right? So 3x squared over 2, this is 1/2. Remember, if we add 1 to that, we get x to the 3/2, and we get 2/3 plus c, okay? This could be done a couple of different ways. This could be done by u substitution, where we let u equal x minus 1. du is dx, okay? And this turns into u squared du. The problem is this extra x I have right here. Well, remember, we would go through and we'd say, well, if I solve that for x, x is u plus 1. And then it was pretty easy to solve this if I distribute this u squared backwards. It becomes u to the 3rd plus u squared du, which is u to the 4th over 4 plus u squared over 2 plus c. And then at the end, I would just plug back in x minus 1. So that's x minus 1 to the 4th over 4. X minus 1 to the 2nd over 2 plus c. Now, another way that you could do this, because this isn't too bad of a problem, you could multiply this out. Like if you happen to know that x minus 1 squared is x squared minus 2x plus 1, and that x times that is x to the 3rd minus 2x squared plus x, and then you go from there, and you would get this for your answer. X to the 4th over 4 minus 2x to the 3rd over 3 plus x squared over 2. And that's actually going to be equivalent to the answer that we got down here. So it's just a matter of whichever way you did it. You'll notice that on certain integral problems, depending on the way you did it, you might get the answer in a different format. Okay, but it'll still be equivalent, the same answer. All right, check it out. I would write this as x to the negative 2. So my integral becomes x to the negative 1 over negative 1. Minus 4x plus c, or I can write that as, bring that back down, negative 1 over x minus 4x plus c, okay? And then my last one, we talked about this idea of splitting up the fractions, where I can go x to the 3rd over x squared is x squared over x squared is 1, and then 2 over x squared can look like that, 2x to the negative 2. When I integrate this, I get x squared over 2 minus x. And then if I add 1, it's 2x to the negative 1 over negative 1. Again, on a free response test, please leave it like that. Multiple choice test, it'll probably be written like this. So probably minus 2 over x plus c. Okay? And then here's a good one. This is the first fundamental theorem of calculus. This says if I integrate f prime, oh actually no, this is a different question, sorry about that. This is a question where it gives me an initial condition, and the initial condition is actually how I am going to find c, because it wants me to find an equation for f of x. So I'm going to be able to find the constant here, okay? Okay, this gives me, if you look here, x to the 3rd over 3, x squared over 2. The 3's cancel out. So this is x to the 3rd plus x squared over 2 plus c. Okay? Now, this initial condition tells me that I can use this, and I can say, okay, if I plug in 1, it should equal 5. So 1 plus 1/2 is 3/2 equals 5. I can call that 10/2. So c is 7/2. So my equation is x to the 3rd plus x squared over 2 plus 7/2. All right, here we go. Now we have another quiz. This is a little question about some particles. Okay. So what it gives me is velocity. Now you guys, I know with velocity, I can go this way and I can get acceleration. I know I'm going to need that for this problem, so I might as well just do it right now. That's 3t squared. And I know if I go this way, I can get position. And the position is the integral of velocity, right? So that's going to be t to the 4th over 4 minus 8t plus c. Now, what this tells me here, though, is that at time 2, its position is 3 centimeters, so x of 2 equals 3. That's what allows me to figure out what this c is, okay? So let's just kind of go over here and say, all right, x of 2 would be 2 to the 4th over 4 minus 8 times 2 plus c, and that equals 3. 2 to the 4th is 16, over 4 is 4. My 16 is negative 12, so c is 15. So I'm going to go ahead and come back up here, and I'm going to say c is 15. And these are my equations now that I have to work with. Okay? All right. Find the equation for the acceleration. Great, I did that by taking a derivative, and it's just 3t squared. Find the acceleration at time 3. A at time 3 equals 3 times 3 squared, which is 27. Acceleration, let's see, second centimeters. Centimeters per second squared, or centimeters per second, okay? So the way that that works, guys, is position is in centimeters, velocity is centimeters per second, and then acceleration is centimeters per second, or per second squared. Perfect. Okay. When is the particle at rest? Okay, we want to remember this, that at rest means velocity equal to 0. So if I set t to the 3rd minus 8 equal to 0, I'm just going to do a quick little solve here. The cube root of 8 is 2. There's a couple other solutions in there, but they're imaginary, so I'm good. I'm going to go ahead and say at 2 seconds, it's at rest. What is the speed at time 0? Okay, speed is the absolute value of velocity. Okay, and at time 0, it'd be the absolute value of the velocity at time 0. So it's the absolute value of, my velocity equation is 0 to the 3rd minus 8. So the absolute value of negative 8 is 8. And speed is the same units as velocity, okay? Centimeters per second, it's just positive. And find the equation for the particle's position. I did that already. That was t to the 4th over 4 minus 8t plus 15. 18 plus minus 18 plus 15. Okay. Nice. All right, now let's look at quiz 2. Memory quiz. No calculators, no notes. This is good. We should have done this in class, but that's all right. We're good. Okay, check it out, guys. Let's do derivative of sine, cosine. Derivative of cotangent, negative cosecant squared. Derivative of secant squared. Now, the integral of secant squared is something, but derivative of secant squared, no. I actually have to do a chain rule. It's 2 secant to the 1st times the derivative of the inside, and the derivative of secant is secant tangent. There we go. Okay. Integrals. Okay, these I can just do. Integral of sine is negative cosine theta plus c. Integral of cosecant cotangent. All right, the derivative of cosecant is negative cosecant cotangent. So it's negative cosecant. This is a reverse chain rule, you guys. Because it has a 2 theta, I need to do a 1/2. All right, nice. This is a u sub problem. And you guys, how do I decide which one to pick u? Well, remember, whatever I pick for u, I want to also see the derivative in there. And what I remember in my head is that the derivative of tangent is secant squared. So if u is tangent, du is secant squared. And so it's the integral of u squared du. Okay, well that's u to the 3rd over 3. So this becomes tangent to the 3rd over 3 plus a constant. Nice. And then this is another u sub. u is x squared, du is 2x dx. So that's 2 1/2. And then this is cosine u du. The integral of cosine is sine. So it's 1/2 sine x squared plus c. Okay, great. Here's another memory one. Let's see how we do. Oh, there's some fun colors. All right. The derivative of cosine, negative sine. The derivative of tangent, secant squared. The derivative of cosecant, negative cosecant cotangent. Okay, great. Some integrals here. The integral of secant squared is tangent. The integral of cosine is sine. The integral of secant tangent is secant. And the integral of sine is negative cosine. But because of the pi x, I do a 1/pi. Okay, awesome. Let's see. On to the next one. All right, we got a few more derivatives and integrals here. Kind of nice going like back and forth. We can really see the differences. Derivative of sine is cosine 3 theta times 3. The derivative of secant is secant tangent. The derivative of cosecant squared, you guys, I got to do a chain rule for that. Remember, it's cosecant squared. So it's going to be 2 cosecant to the first times the derivative of cosecant, which is negative cosecant cotangent. So I would just probably make that whole thing negative, okay? Okay, now we're integrating over here. It's an easy one because the integral of secant squared is tangent, but I got to do a reverse chain rule. This is a u sub, so that's 3x squared dx. So I get 1/3 sine u du. The integral of sine is negative cosine. And so this is negative 1/3 cosine x to the third plus c. Make sure I'm doing all these okay here. If f prime of x is sine and it contains the point 0.05, find an equation for f. Again, this is telling me that I am going to be able to find c. All right? So if I integrate both of these, the integral of sine is negative cosine plus c. So what this is telling me is when I plug in 0, I should get 5. Well, the cosine of 0 is 1. So negative 1 plus c equals 5. So c is 6. So here's my equation for f of x, negative cosine x plus 6. Okay? All right, cool. Moving on. Here we have, let's see, that, I'm going to go ahead and put that together. That's x to the first and x to the 1/2, so that's actually x to the 3/2. The integral would be x to the 5/2 2/5 minus x plus c. Okay? All right, this is a u sub problem. All right, this is u sub. You guys are getting kind of fast at these at this point. All right, so the du is 6x dx, so I need my 6 and my 1/6. And this turns into 1/6 u to the 50th du, which is 1/6. If I add 1, u to the 51 over 51. So I don't think I'm going to, well, I guess I can multiply 6 and 51. What's that, 306? Okay, I was not going to multiply that, but that's fine. 3x squared minus 5. All right. There we go. Okay. This is just a reverse chain rule. Sorry. Integral of cosine is sine, and we do 1/8. Okay. This is a u sub. I'm going to let u be sine x, du be cosine x. This is u to the 4th du, which is u to the 5th over 5. So that's sine x to the 5th over 5 plus c. Okay, cool. And here's another one where the whole purpose of them giving me that is to allow me to find c. So if I integrate both of these, f of x is x squared plus 3x plus c. This tells me, okay, well, if I plug in 2, I should get 3. So 2 squared, that's 4 plus 6 plus c is 3. 10 plus c is 3. So c is negative 7. So my equation is x squared, oh my goodness, plus 3x minus 7, because it's a negative 7. All right. Great, great. Okay. Let's keep going. Use some really fun colors. Evaluate these definite integrals without using a calculator and simplify. Okay, that's x to the 3rd over 3. 3's cancel out. That's x squared over 2. 2's cancel out. I no longer put a plus c, right, guys? Now I evaluate it from 2 to 1. And when I'm evaluating, I always go top minus bottom. If I put 2 in there, 2 to the 3rd is 8. 2 squared is 4. If I put 1 in there, 1 to the 3rd is 1. 1 squared is 1. So I have 12 minus 2, which is 10. Okay, this is a reverse chain rule. The integral of sine is negative cosine. I need to have a 1/3. Okay, so it's negative 1/3. And then I'm going to do this. Cosine of 3 pi minus cosine of 0. Now, really quickly, you guys, if you think about your unit circle, where it goes like 0 pi, 2 pi, then this is also 3 pi. And the point here is the point 1, 0, and the point here is the point negative 1, 0, and cosine is the x coordinate. So 3 pi, the cosine is negative 1, and the cosine of 0 is 1. Okay, so this is negative 1/3 times negative 2, or 2/3. That's what we get for that one. Okay, use geometry to evaluate. This will be fun. The integral from 3 to 5. All right, you guys, that's a triangle. 1/2, the base is 2, the height is 4, so that's going to equal 4. Okay, now if I do this little part down here, that's also 1/2, the base is 2, the height is 4, so that's 4, but that's negative because it's on the bottom. That's positive because it's on the top, so that will go to 0. And then finally I have a calculator question, because this is something that we can't do. There are no integral rules that I can think of right off the bat that we can do that, so we got to do it on the calculator. Okay, so we go Math 9. What was this? 0 to 4. And we're putting in 3x squared plus 5. dx. All right. Sorry, the square root of 3x squared plus 5. I was like, why does it say 3 places of accuracy? Oof. Oh, for goodness sakes, I just need to start over. Okay. 0 to 4. The square root of, it's late, 3x squared plus 5 dx. Whoops. One more dx. There we go. Ah, right, that looks better. So this is just 17.229. Okay? All right, perfect. Okay, cool. F of x is an odd function. I'm assuming that this is, partial graph of f is shown. And the integral from 0 to 2 is 10, and the integral from 2 to 3 is negative 2. I don't know if you guys remember what an odd function is. An even function mirrors itself on the other side. This is an even function. It mirrors. An odd function does like the reverse. okay? So I think the reason it's telling me this is want me to know that's negative 10 and that's positive 2. And that's negative 2 and negative 3. All right, so that's why I said we have an odd function, because now I can figure out the rest of these. Okay, so let's take a look. The integral from 0 to 3 is 10 minus 2, so that's 8. The integral from negative 3 to 3, that's negative 8, positive 8. Everything cancels out. That's 0. The absolute value of f of x from 0 to 3, well, that means it's 10 plus 2. That's 12. It's as if I were bringing that up on the top, okay? Okay, now, this is going backwards, you guys. Instead of going 0 to 2 like we're used to, it goes 2 to 0, so it's reading it backwards. Here's how this works. If the integral from 0 to 2 of f of x is 10, the integral from 2 to 0 is negative 10. It puts a negative in front of it. All right. Now this, you could think about the graph moving up 1. That's actually not how I'm going to do this. Here's what I'm going to do. This is going to be the integral from 0 to 3 of f of x and the integral from 0 to 3 of 1. Now I know the integral from 0 to 3 is 8. What's the integral of 1? Well, the integral of 1 is just 1x evaluated from 3 to 0, which is, we do top minus bottom. 3 minus 0 is 3. So this is x plus 3. So this is 11. Okay, where were we? Okay, so 8, 0, 12, negative 10. That's good. 11. Okay, good. All right, what's the integral from 0 to 6 of f of x minus 3? Okay, now this is a little bit tricky. There's a couple ways you can think of it. First, you can think of this as moving the graph to the right 3. So it's like if I move this whole thing to the right 3, guess what? That point would go there, that point would go there, that point would go to 6. And then I'd get the whole 0 to 6. The other thing that you can do, you guys, is you can, let's do like a quick u substitution. This is something you will see on the AP test. Check this out. If u is x minus 3, du is dx, I can rewrite this as f of u du, okay? And then, look, I have to change my endpoints. Now, these are x endpoints. If I put 6 here, 6 minus 3 is 3. If I put 0 here, 0 minus 3 is negative 3. And u is just a dummy variable, like x is a dummy variable. We could use whatever we want. So since the 0 to 6 is the same as saying, what is it, negative 3 to 3? And negative 3 to 3, I already figured out that that integral was 0. Okay? Now, we have talked about how constants are allowed to come out front. So I can do negative 2 and then the integral of f of x. So that's going to give me negative 2. And then the integral from 2 to 3 was negative 2. So that is a positive 4. All right, awesome. We are cruising right along, guys. No calculators. Great. Okay. That's x to the third over 3. 3's cancel out. That's x squared over 2's. 2's cancel out. And I'm evaluating this from 2 to negative 1. All right. When I plug in 2, I get 8 minus 4 plus 2. When I plug in negative 1, I get negative 1 minus, negative 1 squared is 1 minus 1. Interesting. So I get 6 minus negative 3. So I get 9 for that one. Oh gosh, this is a u sub problem. U is 2x squared plus 1. Du is 4x dx for 1/4. So that's square root u du. Now, to integrate square root u, I'm going to take that and I want to go u to the, let's just see here, 1/2 plus 1, u to the 3/2, 2/3. Now, I could simplify that to 1/6 u to the 3/2. And I could change that back into x's, but I actually think I'm just going to change my endpoints. I kind of like that better, right? If I plug in a 2 right here, I get 8 plus 1, I get 9. If I plug in a 0 right here, 0 plus 1, I get 1. Okay, and now when I evaluate this, Let me go ahead and leave the 1/6 out front. It's 9 to the 3/2 minus 1 to the 3/2. Well, guys, 9 to the 3/2 means the square root of 9 to the third. The square root of 9 is 3. 3 to the third, 27. 1 to the 3/2 is 1. So this is basically 26 over 6. Leave it like that. Or that's 13 over 3. You can simplify down to there. Okay? Perfect. All right, here we go. This, it does want me to simplify all the way because technically I could leave it, you know, with signs in it, but it says simplify, so we'll do that. Okay, integral of sine is negative cosine. Reverse U substitution tells me to put a 1/2 right there. So I have negative 1/2, and then it's basically the cosine of, now 2 pi over 6 is pi over 3, and then it's the cosine of 0. And if it hadn't said simplify, you are allowed to leave it like that, okay? But since it did tell me to simplify this, whoops. Let's do that. I need to know the cosine of 3 pi over 2. You guys can go look that up on your trig chart. It's 1/2. The cosine of 0 is 1. So it's negative 1/2 times negative 1/2. So this equals 1/4. All right. Oh, nice. Guys, look, derivative of an integral. This is the one we really like. Second fundamental theorem of calculus. If they take the derivative of the integral, goes away, that pops in there. So that's x squared squared times the derivative of the thing I brought in because of chain rule times 2x. And obviously that x squared squared you could put as an x to the 4th. Okay? All right, we're really rolling here. Let's go. Let's see. Differentiate. Easy. The derivative of ln is 1 over whatever I'm taking the ln of times the derivative of the inside. There's another chain rule. I do the 3 first. 3 ln of x squared times 1 over x. Whew, this one I have a little bit of trouble remembering. I remember log is like ln. It's supposed to be 1 over. It's like ln. Then I put this extra ln of the base on the bottom because this is log base 10. And I still have to do a chain rule. So it's times 2. Okay, sorry, I had a little technical issue, so we got to start back over again at number 4. Here we go. Okay, so 4 and 5, these are both U sub problems. Let's get over here. Erase. Okay. Cool. These are both U sub questions, guys. This one, U is x squared minus 2x. du is 2x minus 2 dx. So this turns into 1 over u du. And that one we know, 1 over u is ln u. So my answer is ln x squared minus 2x plus c. Now this is a little bit different, even though my u and my du are the same. U is x squared minus 2x. du is 2x minus 2 dx. The difference is that when I go to plug this in, that's 1 over u to the third du, which is not an ln question, right? We bring that up as a u to the negative 3, so that the integral is u to the negative 2 over negative 2. Again, you guys, if it's not multiple choice, just do this. Negative 2 over negative 2. Okay? You don't have to bring it down. You don't have to do any of that other stuff. That's all good. Okay, perfect. And here is another u sub problem. This time u is ln of x because the derivative of that is 1 over x dx. And so this turns into u squared du, which is u to the third over 3. So it's ln of x to the third over 3 plus c. And, okay, this is a u sub, but remember, if you guys remember, we don't know the derivative of tangent or cotangent. We don't know those. So actually, every time we have to take, or sorry, we don't know the integral of tangent or cotangent. Every time we do a tangent or cotangent, we have to switch it to sine over cosine or cosine over sine. That's just one of those things you got to remember. Because then, okay, u is cosine pi x. Du, the derivative is negative sine pi x times pi. So I need a negative and a pi here, which means I need a 1 over negative pi out there. And this turns into 1 over u du, which is ln u. So I have negative 1 over pi ln of cosine of pi x plus c. All right, awesome. Let's finish up with 6.4, and then I'll make another video for 6.5 through 6.8. Okay, this one's going to go quick because it's a bunch of derivatives. X to the fifth is 5x to the fourth. 5 to the x is 5 to the x ln 5. Told you I always kind of forget log, but it's basically like ln, so it's 1 over x. And then I put the ln of 5 on the bottom. Gotta always make sure, but yeah, that's right. Now this, you guys, look, that 5 I can move down in front, right? And call this 5 ln x. And then the derivative is 5 times 1 over x. That's a really fast way to do it. You could also do a chain rule and it'll simplify, okay? All right, this one is tricky. If you guys remember, anytime we had a variable in the base and a variable in the exponent, we had to do something called logarithmic differentiation. Okay, here's how it worked. We would start by taking the ln of both sides. So it says ln of y equals, and the reason I do that is because I'd bring this down in front, 5x ln x. At that point, I would take the derivative, but I'd do it implicitly, okay? Because ln y is 1 over y, y prime, or dy dx. This is a product rule. Derivative of the first times the second plus first times derivative of the second. Now, I can simplify the x's here so that I get 5 ln of x plus 5. But you guys, the original problem asked us to find y prime or dy dx. And I have this 1 over y here, and we don't want that there. So what we're going to do at the very end is just multiply the y over to get it on the other side, right? Now, sometimes it will say times y. But if it doesn't, let's go all the way back to the beginning. What was y? X to the 5x, okay? Lots of good review questions and stuff on here. Got a couple of integrals. How would I integrate 5 to the x? That's just a rule we memorize, 5 to the x over ln 5. How would I integrate 1 over 5x? Well, you guys, that's a constant. This is basically asking me to do 1 over x. And I know that that's ln of x. So that's how you do those two, okay? Okay, perfect. We're going to do 6.5 through 6.8 on our last video.